Welcome back to the hyperbolic suffering chamber. We are back once again. We have more problems to do, more things to worry about, and also more things to put into this room. So I have at this point, I'm just ordering more boxes and they're empty. I'm just putting them in here just for the sake of putting them in here. But this is the hyperbolic storage chamber, and what we're actually trying to store is new information in our brains. So things have been going well recently, I think. We're reaching a nice stride, reaching a nice gait. So I think at this point we just have to keep working at it. It was interesting because I remember thinking back, anytime I watch the old videos, I cringe. And by old, I mean even yesterday's video. I watched yesterday's video back and I couldn't even get through it. I might actually be insufferable. So yeah, it was hard to get through yesterday. I don't know how yeah, but this is all to say, in the beginning, I remember things being a little bit more difficult. And they're not as difficult now, which is kind of dope. That being the case, I've come to accept that 40 to 45 minutes to an hour of my life will be gone for till the end of time until we finish LeetCode. So maybe they'll give us an expansion pack. Honestly, if we do all the problems, maybe we'll just switch to weekly at that point. But we're getting ahead of ourselves. We'll see when we get there. That's about 400 days out. So, you know what? What if we make a diary and we just say 400 days out? 400 days. You know, I have an idea. Maybe we'll make it like The Office. Michael records a video for his future self when he thinks he'll receive good news, and so we'll do the same, right? We'll make a video and we'll just be like, yeah, how does it feel to have 500? How does it feel to have all the LeetCode problems done? And we'll just set it to release 200 days from now, and I wonder how we'll feel because all the problems will be done. So that could be pretty cool. But I'm getting off topic again. This is all to say, things are more difficult in the past. Things are still difficult now. My brain is a little sauced. I'm running out of brain sauce. Long day at work, but it was rewarding. I have to admit, it was rewarding. But I can tell that my mind is a little... tight. So we're going to have to reach a relaxed state to truly cook. And I can always tell when I'm a little more tightly wound than usual. Usually from long bouts of focusing, like at work or LeetCode, I'll come out and my speech will become like it is now. Or I have like a lot of things, like I might blink a lot, or I'll be overly aware of everything that's happening. Which usually happens when I'm focusing for too long. That's probably where we're at right now. And we still have to do LeetCode today. We still have to work out. So maybe we'll eat a large sinful meal to recuperate our brain, to recuperate some brain sauce. I remember reading a book, and it said, I think it was David Goggins' book, Can't Stop Me. Or maybe it was a different book. I don't remember. At this point, it's just a soup in my head. But they mentioned that the only thing that could rejuvenate people when they thought that there was nothing left within them was dopamine. So, this is to say, I'm going to hang, at the end of the session, a nice, fat, thick, oily, greasy slab of pizza. And yeah, I'm already back. I can feel my heart rate rising more than it will be when I'm eating the pizza. And I can feel my vision focusing. And I can feel my mind, the focal point of my mind slowly getting. I have returned. I had to step away to fix something. But after that, we are definitely doing a shorter session. So We're gonna try and lock in for about 30 or 40 minutes, and we'll see where we end up. And yeah, hopefully we can still make some good progress today. A little bit every day goes a long way, so we shall see. And yeah, so that's where we're at. So this is what we're gonna try and do today. Given two 0-indexed integer arrays, nums1 and nums2, return a list answer. So we have two 0-indexed integer arrays, nums1 and nums2, return a list answer of size 2, where answer sub 0 is a list. Answer sub 0 is a list of all distinct list answer of size 2, where answer sub 0 is a list of all distinct integers in nums1, which are not present in nums2, and answer sub 1 is a list of all distinct integers in nums2, which are not present in nums1. What's the opposite of union? We pretty much want to know the list of integers in nums1, which are not present in nums2, and a list of all distinct integers in nums2, which are not present in nums1. If that's the case, I think we can just do this with two sets. It's a list of all distinct integers which are not present in nums2. So you have 1, 2, 3 here. Right, and nums2 doesn't have 1 or 3. Okay, so it looks like we should just load these into sets. Do set 1 is equal to a new set of type number. And then we'll just say for const num of nums1 set 1 dot add num, and then we'll duplicate this, change this to nums2, and then change this to set2, and then for answer we'll return answer like so, and then we'll just do what they wanted us to do. So a list of distinct integers in nums1 which are not present in nums2. So we can just say for const key of set yeah, and now it seems like the IntelliSense is gone, or I forgot what this is called, but it feels like sometimes it's here and sometimes it isn't. So I do set 1 dot, we don't get anything. So maybe a set 1 dot keys. I'm just gonna print console.log key to see what we get. So we do get 1, 2, 3. So we're just gonna say answer sub 0. Say if set 2 dot has key. I mean, if it doesn't have key, we're gonna do answer sub 0 dot push key. Change this to set 1, then we'll change this to answer sub 1. I think this should be n times m time, where n is the number of elements in nums 1 and m is the number of elements in nums 2. Do n plus m here, then we do n potentially times m operations. No, we do n, right, and then we do m. Actually, we n plus m, I think. So then we'll try find lucky integer in an array. Given an array of integers r, a lucky integer is an integer that has a frequency in the array equal to its value. Return the largest lucky integer in the array. If there is no largest lucky integer in the array, return -1. How can there be no largest lucky integer? Oh, because you need to have values. Okay. So it looks like we can create a map and then filter out all the numbers for the ones. We can filter out, we can load it all into a map, and then we could spread it into an array of tuples. From there, we can filter out all the tuples that have an occurrence that doesn't equal its key, and then we can do linear time to find out the largest one. If that array is empty, we return -1. So we'll create a map of number to number, and we'll say for const num of r, we'll say map.set num equal to if map.has num, right? And we want to do map.get num plus 1, otherwise you want to set it equal to 1. From here we can say tuples is equal to spreading the map into an array of tuples. Then we'll say for each tuple, right, you want to filter, we'll keep all the tuples for which tuple sub 0 is equal to tuple sub 1, right? If tuples dot length equals 0, here we can return -1. And then we'll let largest lucky equal tuples sub 0, and then we'll go through the array again, and we'll say for const tuples largest lucky is equal to math.maps of largest lucky or key or awk, which is the same because they equal each other. So I'm satisfied with that one. So let's try count special quadruplets. Given a zero-indexed integer array nums, zero-indexed integer array nums, a zero-indexed integer array nums, return the number given a zero-indexed integer array nums, given a zero-indexed integer array nums, return the number of distinct quadruplets a, b, c, d, such that num sub a plus num sub b plus num sub c equals num sub d, and a is less than b is less than c is less than d. You can't sort because the relative ordering of the indexes must be sorted in ascending order. I guess I'm trying to pre-optimize. I think we could, if we pick 3, if we try and brute force, you pick 3, right? Then we'll pick 3, right? And then we'll pick 6, and then see if any of these indices give us any of these values, and they don't. If you picked 1, 2, and 3, then check if that number existed. We're back. This is similar to count triplets. I guess I'm trying to figure out what the runtime complexity would be. We take 1, you run with that, right? With 1 index forward, you grab 2, you run with that, go 1 index forward, you grab 3, and then you see if you can make any new triplets that exist. Then you can just iterate forwards and check if that value exists after the current index. You can't use maps and you wouldn't know, or it wouldn't be that much faster. It looks like we'd have 4 for loops, but what would the time complexity of that be? If we do 1 run with n equals 4, we do 1, 2, 3 runs. 1, 2. It's hard to know how many operations that would be. Since we need at least 4 indices, we can pretty much skip any array that is while A is less than pretty much want it to only run for this first index. So A, which is 0, is less than nums.length minus 3. And it probably doesn't even matter, actually. It might just be easier to read if we just kept it normal. Seems fast. I feel like when you see 3 for loops, I want to think n to the 4th, but that's only when we're actually going to be doing n operations. We actually do less operation. I feel like this, I don't know what the time complexity is for something like this. So we have A plus B in a collections default dict. So for C in range. So they're going in order of the array in reverse. For D in range, C plus 1. Res plus equal A plus B. I don't understand. So we have res is equal to 0, length is equal to nums.length, count is equal to new hash map, and then we do count.put num sub length minus 1, which is the number, minus num sub length minus 2, set the occurrence equal to 1. B is equal to length minus 3. B is greater than or equal to 1. B minus minus. All right, let's just write out what happens. We'll just follow it. Instead of res, we'll call this count. And anywhere we have count, I just realized this is the wrong problem. Then we have count. We'll change this to map. Get see if this works. This seems the same speed as mine. It's not exactly clear how this is O of n cubed. How about this? We go back to this one, and we're also going to count ops. Each time we go forward with A, that'll be one operation. Each time we do this, that'll be one operation. Each time we do this, that'll be one operation. And then at the end, we should know I guess numbs on length is less than feet 50, so maybe it's just not that big of a deal. But what if it wasn't? I guess this is n cubed then. I mean n to the 4th power. This is somewhere between n cubed and n to the 4th power. So it's definitely not, yeah. Looks like we got lucky here since this problem is allows you to brute force it. I guess if they didn't allow us to brute force it, we would definitely be in trouble. I think we'll stop there for today.